Hello, welcome to R Basics. In this module, I'll be speaking to you about creating histograms in R. So let's begin. Now, histograms are created with the hist command in R. The basic syntax for creating a histogram in R is as you see it here. Now we're going to go through each of these arguments one by one briefly here, and then we're going to go through an illustration, an example, using actual information for each of them. Now, Y is a data object containing the values used in a Y-axis. Breaks is the algorithm for calculating the X-axis breakpoints, also referred to as groupings. Call indicates the color for the bars. XLab is the X-axis label. YLab is the Y-axis label. XLim specifies the X-axis length, and YLim specifies the Y-axis length. Now, to start our example, we're going to create a data object called ages, which is a numerical vector containing ages of a family tree. So this is a statement we're going to use to create this numerical vector. So we're going to copy, and then we're going to put it in RStudio. And there we've created the object ages. And just to verify, it is a numeric vector. Now, the basics of doing a histogram is just to employ the Y argument, which is labeled here ages. So let's do that right now. And you get the basic histogram. Now you'll notice that the increments here are increments of 10, and you notice the Y-axis is the frequency, which is what we would expect. Now, the standard algorithm for calculating the X-axis breakpoints is the Sturgis algorithm. So without specifying it, and I did not specify it here, the Sturgis algorithm is a default, and that's what I used. Now, the two other standard algorithms that are used are the Scott and the Friedman-Diaconis algorithms. Now, you can use abbreviations for all three of these algorithms. ST for Sturgis, SC for Scott, and FR for Friedman-Diaconis. So we're going to go ahead and just illustrate how we can use each of these. So in this statement here, I'm going to be using the Sturgis algorithm. So we'll just copy and paste it in. And as we expected, there'd be no difference here in the appearance of the histogram. Now we're going to use a Scott algorithm, do a copy and a paste. Now what you notice is the X-axis, our breakpoints are in increments of 20. All right. Now the third one is the Friedman-Diaconis algorithm, and we'll just do a copy and we'll paste it in. And there's no change. So in some cases, the results are identical to what you saw using the previous algorithm. Now, you can also specify X-axis breaks manually. Now, so what we're going to do is we're going to set breaks to be a numeric value, in this case a value of 10. So I would expect, making it the breaks a value of 10, I would expect the identical results with the Sturgis argument. I mean with the Sturgis algorithm. So let's see if this works that way. And that looks very familiar. That came out as we expected. Now let's just change it so that we're using just 2 breaks as an extreme. And you'll notice we just have 2 breaks. Okay, so that's another option that you have. Now you can also create a histogram with unequal break ranges. So in this situation, I'm going to specify my breakpoints at the value of 2, 20, 60, and 100. So let's go ahead and copy that and paste it in. And when we do, you'll notice that the initial breakpoint begins at 20, and then the next break, begins at 2, and then the next break is at 20, and then 60, and then 100, which is what we specified up here. Now you notice the other thing is on the Y-axis, now it displays density instead of frequency. So if you did the math, I believe the values under each of these bars would equal a value of 1. Now, let's go on and see what other things we can do. So we can use the color argument, or COL. Now you can see that all the colors available using the colors command. So if I went as so, you could see all these colors. You could see 657 colors here. These are the names here on the right, of course, and then on the left side you see the numeric values for the ones that are on the far left. Now we can go ahead then. We could specify either a color either by name or by number. So in this example, I'm going to make call or COL is equal to just plain old blue, and I put it in single quotes as you see it here. Let me clear this. All right, and we got a strong blue. Now I'm going to change that to COL is equal to 550, and we're going to go ahead and do a copy and paste. And here you have the something akin to I don't know, just kind of a dark pink, if you will. At least to my eyesight, that's the way it looks. Now let's go ahead and change the axis labels. We do that using the XLab and the YLab arguments. So very simple. I've illustrated here. We're going to make XLab equals ages of family members in single quotes, and YLab is equal to age frequency, also in single quotes. So let's go ahead and copy and paste that in. And there you have it. We have our X and Y axis labels that are now changed. Now, the last thing that we're going to do here is we're going to change the axis length. And we do that using XLim and the YLim arguments. So in this example here, I'm going to do here at the far right. You can see I'm changing XLim so that XLim begins at a value of 0 and it goes up to a value of 120, and then YLim goes from 0 to 20. So let's go ahead and copy that in. And there you have it. So you have the x-axis going from 0 to 120 as we specified, and then the y-axis going from 0 and it goes all the way to 20. Now at this point, we've actually completed this module. I want to thank you for watching R Basics. Please check the R Basics channel for other modules which may interest you. Thanks and have a good day.